This is review recording 1A and B to accompany instructional recordings 1A and 1B for Section 1.2 of Unit 1, Chapter 1, Mathematics 2200. I'm glad to have you along. We're going to focus on using the formulas for the sum of an arithmetic series. This first example asks, the general term for a sequence is given by t sub n equals negative 11n plus 11. What is s sub 60 for the related series? So if you recall, there are two formulas for the sum of an arithmetic series. What's the easier one to use in this case, or is there any difference? Let's see. To use this one, I'd need to know term 1, what I can calculate that from this formula. And I'd need to know my n value, which is going to be 60. So I got that. And I'd need to know t sub 60, which I can also calculate from here. So that's not too bad. Over here, I'd need to know my n value, which I have. My term 1, I can calculate from the formula. And I got my n value. The constant difference is the coefficient of n in the sequence formula. That's negative 11. But I think I'll still stick with this formula. We note that n equals 60 for this problem. Term 1 equals negative 11 times 1 plus 11, which works out to, negative 11 there. That works out to be 0. Oh, beautiful. Term 60. That's negative 11 times 60 plus 11. That's negative 660 plus 11, which gives us negative 649. How nice is that? Therefore, s sub 60 is equal to 60 outside of term 1 plus the value of term 60 all over 2. Well, we've got 60 outside of 0 plus 649 all over 2. Let's fix up that little 0 there. So we've got, I'll divide my 2 into my 60 to go 30. So I really have 30 times 649, which gives me 19,470. C is the correct answer. Example 2. Find the sum of all the multiples of 7 between 1 and 1,000. Begin by writing them out. We have 7 plus 14 plus 21 plus 28, etc. The question is, what's the last multiple of 7 before 1,000? A little bit of trial and error determines that that's 994. We notice that there's a common difference, as we would expect, of 7. That's our common difference, and we've got to find the sum of all the multiples of 7. So the question is, which formula do we want to use? Let's examine our formulas. We need to know the n values for both. Well, we don't have that, so we're going to have to work equally hard at that. We know term 1 for both formulas. We know the constant difference over here. Here we would also need to know the value of the nth term, which we do. It's 994. So again, either formula is pretty good. A related sequence formula. We will go back to that t sub n equals t sub 1 plus n minus 1 times d. 994, because we don't know the n value, but we do know the nth term is 994, equals term 1, which is 7, and n we're looking for, constant difference, is also 7. So we have 994 equals 7 plus 7n minus 7. These 7's cancel off really nicely. And we get 142 equals the value of n. So again, I will stick with this first formula. I think S sub 142 is what we're looking for, because we have 142 terms. Equals 142 outside of the first term plus the 142nd term all over 2. Well, very nicely, we've got the first term is known to be 7. The 142nd term is 994. It's all dividing by 2. I'll divide this 2 into this 142 to get 71. So I'm left with 71 times 1001, which gives me 71,071. In closing, there are two formulas that can be used to find the sum of an arithmetic series. I've listed them for you over here. The choice of formula should be based on what is already known and or can be more easily found. It may be necessary to first use the formula t sub n equals t sub 1 plus n minus 1 times d, where n is a natural number, for the related sequence in order to find the value of t sub n, t sub 1, n, or d, depending on the problem.